All right, before I do a completing the square example, I just want to show you how you can actually do completing the square. You know how you have to do the thing where you have to divide this by 2 and then square it, and then you have to add that number on? Well, you can actually do it with fractions as well. And so let's say I had something like this, and then it said equals something else, right? And I wanted to know, well, what do I have to add on to this to complete the square? Well, I want to remind you that what I'm going to do is I'm going to take the number in front of the x, which in this case is 2/9. I want to half it and square it. But instead of putting it over 2, what I'm going to do is I'm going to multiply it by 1/2. So all you have to do is multiply by a fraction of 1/2 and then square it, okay? And so what is this going to become? Well, to multiply, I just go across. 1 times 2 is 2. 2 times 9 is 18. And then we square it. But I do want to point out here that we can reduce 2 over 18 to 1/9. 2 divided by 2 is 1. 9 divided by 2 is, or 18 divided by 2 is 9. And that becomes 1/9 squared. And if I were to square this, it would be 1/9 times 1/9. And 1/9 times 1/9, we do 1 times 1 is 1, and 9 times 9 is 81. And so this is what we would add on the end. We'd add on 1 over 81, okay? Now, another way you could have done this is, look here, when we did 1/2 times 2 over 9, we could have just canceled the 2's and gotten 1 over 9, but I don't know if you feel comfortable doing that, okay? So you can do it either way. I think I want to do another example kind of like this. All right, so let's say this is what we wanted to complete the square on. And so again, it's a fraction, 4/5. So what we're going to do is we're going to take the number in front of the x, 4/5. And remember what I said is we're going to multiply it by 1/2. And then we're going to square it. Well, 1 times 4 is 4. 2 times 5 is 10 squared. So what we have is 4 over 10 squared. But this can be reduced. 4 is divisible by 2 and 10 is divisible by 2. So it becomes 2/5 squared, which becomes 2/5 times 2/5, okay, which becomes 2 times 2 is 4, and 5 times 5 is 25. And so this is what would be added to the end. So it would become x squared plus 4/5 x plus 4 over 25. Okay, I just wanted to show you that you can actually do this with fractions if you had to. All right, so here's a quadratic equation, and we're going to do completing the square on it. So remember, the first thing we do is we want to get rid of the constant. We're going to add 7 to both sides. So we wind up with x squared minus 5x, plus 5x is equal to 7. Okay. Now what we want to do is we want to take half of this middle number here, 5, and we want to square it. So the way we're going to do that is we're going to do 5 over 2 and then square it. Now this can't be reduced, so we're just going to do it as 5 over 2 times 5 over 2. And that's going to be equal to 5 times 5 is 25 over 2 times 2 is 4. So we have to actually add 25 over 4 to both sides. So add 25 over 4, add 25 over 4. Now you may be thinking right now, is there anything I could have done to stop from having to deal with fractions here? Yes. You could have, at the very beginning, decided to use the quadratic formula instead of completing the square. But because we're doing completing the square, we know we have to take half of the middle. This middle is an odd number. Half of an odd number is a fraction. If that's an even number, it's a lot easier to complete the square. I'll do one of those in just a few minutes. So now I have x squared plus 5x plus 25 over 4 is equal to. Now in order to add this, I want to turn 7 into 28 over 4. So 28 over 4 plus 25 over 4 is 53 over 4. Okay? And so now, remember, now I have to take this and I have to turn it into a parenthesis squared. Okay? And what I'm going to have is I'm going to have an x and then half of the middle number, which is 5 over 2. So I'm going to have x plus 5 over 2, and then this is going to be equal to 53 over 4. And now what I have to do is I have to take the square root of both sides, and I have to put a plus or minus on this one. And so this becomes x plus 5 over 2 is equal to plus or minus. Now, the square root of 53 over 4 is actually the square root of 53 over the square root of 4, and the square root of 4 is 2. Okay? And so now what we're going to do is we're going to subtract 5 over 2 from both sides. And remember, when I do that, subtract 5 over 2, I want to put it in between. I want to put it in here where the plus or minus is. So I'm going to put x is equal to negative 5 over 2 plus or minus 53 over 2. Okay? And so now I'm going to turn that into two different answers. I'm going to have x is equal to negative 5 over 2 plus, this is square root of 53, plus square root of 53 over 2. Okay, that's one of our answers. And then, I mean, really, we could write it as x is equal to negative 5 plus square root of 53 over 2, and that's one answer. And then the other one is going to be x is equal to, where are we? Minus negative 5 over 2 minus the square root of 53 over 2. And that actually winds up being x is negative 5 minus square root of 53 over 2. You might say, man, I really should have used the quadratic formula. Well, yeah, but I mean, you still would have gotten this answer. Look, this is in the form of the quadratic formula. We have negative b, which is negative 5, plus or minus the square root of b squared minus 4ac. That wound up being 53 over 2a. A is 1 there, times 2 is over 2. So you wind up getting the same answer with completing the square or with the quadratic formula. The big difference is that with the quadratic formula, we wouldn't have had to deal with these fractions. So if you see this term here, if that's an odd number, you may want to think about doing the quadratic formula instead of completing the square. But I at least wanted to show you that you can complete the square even when this number is odd. In the next video, I'm going to do a couple examples where the number is an even number.